Welcome to the lecture 2 of module 7. In this module, we have been discussing on heat exchanger, and in the last lecture, the first lecture of this module, we have discussed the various types of heat exchangers that are available, and we have discussed in details about that configurations as well as the construction of a double pipe heat exchangers, and then we have started discussing on cell and tube heat exchanger. And we should understand that cell and tube heat exchanger is very widely used and the most common heat exchanger, particularly for chemical engineering process industries, and therefore, that we should have a thorough idea about the different parts of the cell and tube heat exchanger, their functions, and how they are being fitted into the heat exchanger. So, to continue with that, whatever we have discussed in the last lecture, in today's lecture, first we will start with a single cell and tube heat exchanger, and then we will see the different types of cell and tube heat exchangers possible. Okay. So, first we will start with to see that various parts of a cell and tube heat exchanger. So, now onwards we will tell that cell and tube heat exchanger as SHE and simple heat exchanger as HE. So, I will use this. This is cell and tube heat exchanger abbreviation. And this is heat exchanger. So, we had discussed in the last lecture, we had discussed about the cell, we had discussed about the tube, how the cell is being made, and what are the different types of pitching arrangements for the tubes, and how to calculate that flow area through the tube pitch, and all the material of construction of the tubes and cells already we have discussed. Now, today we are going to see first that first thing we are going to discuss is the bonnet and channel. So, bonnet and channel. So, two different terminologies are being used. If we see the heat exchanger, that tube seats, there should be an enclosure. Okay. You can see there that this is the enclosure for the tubes. This is another kind of enclosure for the tubes here, and this is the cell side. And in case of floating head also, if you have a floating head, so you can see that there is an enclosure for the tubes, and this is the enclosure for the cell. So, there can be some enclosure, there has to be some enclosure for the tube side fluid, so that the tube side fluid will be kept over there. And these enclosures can be of two different types. One is called bonnet, another is called channel. The bonnet means that it is a bonnet, basically you can say that this closure is a channel depending on the bonnet, or channel depends upon the type of construction that is being made. So, bonnet is an integral cover. You can say that a bonnet has integral cover. So, that means bonnet will be using when we do not require any nozzle to be fit in. So, if we see again that this is the part, this part is called bonnet. Okay. Here this is called bonnet, here this is called bonnet, and we can see that there is no further nozzle is being added to this. So, this is called bonnet, and so it is an integral part of the enclosure. Okay. And there is no nozzle being attached, whereas a channel can have a removable cover. So, this part is the channel cover. So, channel, this is the whole thing is called channel and this part is called channel cover. So, a channel can have removable cover and it is basically consists of two parts. This channel consists of two parts. One is called stationary channel and the second part is that channel cover, and it is called also blind flange. So, if we see that there can be this can be straightforward like this also, then it will become a blind flange like kind of things. So, this is the channels will be fitted with some nozzles. You can see that there are some nozzles are there that is fitted with this. So, channels are fitted with nozzles. Okay. Now, the second part next part of this is that pass partition plate. So, this is very important. We can have pass partition plate in tube side, you can have pass partition plate for the cell side. So, for tube side plate and we can have for cell side plate also. So, what are these? Tube side plate and cell side plate, and what is a pass partition? The pass is, if we see again, that pass means that pass partition plate is that you can see that this is the pass partition plate and we will see that this is the tube side pass partition plate. So, what happens is when we have this kind of pass partition plate, so the fluid is going first, the tube side fluid is entering like this, it is going through these tubes, then coming back and then going through these tubes and going back. So, a fluid is a fluid element, every fluid element because of this partition, only one partition. So, because of this partition, a fluid element can be in the heat exchanger twice. If this partition would not have been there, then what would have been, that fluid element would have come directly here and would have gone to the other side. So, the tube should have that fluid of the tube side fluid should have come into one side and should have left the other side from the heat exchanger. In that case, the fluid elements, every fluid element is passing through the cell and tube heat exchanger only once. So, then it is called single pass, and when we are putting some partition plates, that means we are increasing the number of passes. What is that? It is the number of passes, means the number of times a fluid element can be in the heat exchangers. So, when we are putting a pass partition in the tube side fluid, then we will be getting the tube side fluid element will be twice. Similarly, we can increase the number of partitions. And for the cell side also we can have pass partition plates. So, then it will be in the cell, we will see that. So, by changing the partition plates, what we can say is that number of passes indicates the number of times the cell or tube side fluid traverses the length of the heat exchanger. So, therefore, we have to use, there are two type of plates, one is called cell side plate and one is tube side plate, and as we understand, the tube side plates they will be in the nozzle or in the bonnets, while the cell side plates these will be in the cell, throughout the cell. Okay. Now, what happens is that there are different types of cell and tube heat exchangers possible depending on the number of passes. We call it to be 1:2 cell and tube heat exchanger. One is to, the common type are 1:4, then 2:4, and then we have 2:6. These are the very common type of heat exchangers. These are called multi-pass heat exchangers are there. 1:2 means once this indicates that one represent, the first one represent the cell side pass. So, in this first number, so if I say that M:n cell and tube heat exchanger means indicates that M indicates number of cell side pass and N indicates the number of tube side pass. So, then what actually is happening and why we are going for these kind of things, that why to improve the or increase the passes. If we increase the pass, we can understand that that availability of a particular amount of fluid to flow through the area is reduced. So, when we are increasing the number of pass, we are decreasing or reducing the flow area. So, therefore, what will happen with pass increase in number of passes, what we can expect in reduction of flow area for the fluid elements, for the fluid. This will increase in flow rate, and that means it is increase in turbulence, this will increase in heat transfer coefficient. But at the same time, what we are going to get is there will be increase in pressure drop also. So, now we have to optimize and to find out that whether we should go for more number of passes or not. And then another point is there, when the amount flow of the fluid, say suppose tube side flow is small, then what we can do, we can increase the number of passes to give more flow rate. So, if the total flow of per unit time in the tube side is small, in that case the velocity may be too small. So, we may put some passes and increase the flow rate. Similarly, the case for a cell side case, if the cell side flow is a bit small, then what we can do is that we can put a cell side pass and try to see that flow rate is increased, and though there will be some amount of pressure drop, but at the same time we will be getting some kind of higher heat transfer coefficient. So, heat transfer performance will be good. Normally, the even passes are used, your odd passes are normally not used. So, odd passes like say 1:3 or 1:5, okay, or 3:5. So, this type of passes are not used. Okay. Now, if we see that this figure gives us an idea about the pass, if we see that in this figure there are two tube side passes and there is one, this is the, I am sorry, this side there are two tube side passes and this side there are only one tube side pass, whereas here we have one cell side pass. So, therefore, what is happening in this particular picture, if you see, the fluid is coming from this side and then it has got how many routes, that tube side fluid is crossing the heat exchanger 4 times. One fluid element in the cell and tube heat exchanger crossing the heat exchanger 4 times. You can see that it enters from here, then it is going like this and then it is passing through this. So, this then it is coming here and then this fluid element is entering here and then again it is going like this and coming out. So, there are, we can see that 4 times it is passing through, and to have these 4 passes we need to put 3 partition plates. So that we can understand. While we had 2 passes, we had to put only 1 partition plate. Here we had to put 3 partition plates, and these 3 partition plates are placed in 2 different sides. In this side, it is that this is one side, there are 2, and in another side there is 1. These are all tube side partition plates. And also in the cell side, we are seeing that there is a partition plate. Therefore, the cell side partition plate, it will be horizontally, and it will be all through longitudinally covering this, and therefore, so that no fluid from one side of the partition of the cell can move to the other side of this. So, this is what is happening. Okay. Now, therefore, in the cell side, it is a 2. We can say that number of pass in the cell side will be 2. So, cell side fluid will pass through this heat exchanger twice. Okay. Now, there are some other points. So, it is something about the partition plates we have seen, and number of passes we have seen, and then we are going to go for the nozzles. So, nozzles are also very important. If you see that important thing in case of cell and tube heat exchangers, and it is, we can say that these are the nozzles. These are the nozzles. So, nozzles are basically some pipe sections, small pipe sections which are welded to the cell or the tube. So, nozzles are needed. Nozzles are needed for both tube side and cell side. So, these are, we can say, small pipe sections of suitable size, you can say, size, and welded to the shell or bonnet or nozzle, or the bonnet or the channel. Okay. Now, in addition to this, we can see that all the nozzles will be in the other part of the nozzle will be fitted with a flange. Other side of the nozzle is fitted with a flange. The reason is this flange will help to couple with another flange that will be fitted with the pipe. So, this is to fit the heat exchanger with the source or the supply line or that or the delivery line from the heat exchangers. Okay. So, to connect with the pipelines. So, this is with the flange, this is to connect with pipelines. Okay. That we can see that it is always there. And then another important point is that particularly this is happening with the cell side. In the cell side, just below the nozzle will be having a plate that is called impingement plate. Impingement plate, or it is called impingement baffle. So, what is this? We can see that this is very important. This is very important in case of heat exchanger. We can see that here it is not seen in the previous diagram. We can see that this here, this is called impingement plate. This one is called impingement plate, and it is written here the impingement baffle or impingement plate. The idea behind is that when a fluid, so it will be there particularly when there will be inlet, it will be there to the inlet side. So, when there is a fluid which is entering like this, so it will be suddenly, if it directly falls on the tube bundle, then there is a possibility to the damage of the tube bundle by different means. So, to avoid that damage, okay, the fluids are stopped to directly enter into the or directly hit the tube bundles or tubes. So, that is the impingement plate. What it does is it stops, we can say the stop direct hitting, heating the tubes by the cell side fluid. Okay. So in that case, what is the possibility, what is the problem that can happen? It hits directly the tubes. The problem can faced, problems that can be faced in case of direct heating these are, we can say that erosion of tubes, then cavitation due to buckling of tube bundles. Okay. So, these are the problems and that can happen, and then vibration of tubes. Okay. So, that may make lose or may enable some leaks to be created due to the vibration of the tubes. So, these are the possibilities that when it is just striking or hitting that tubes, there could be some erosion of the tube surface, and these erosions will be more this erosion when if have dust or it takes place due to presence of dust particles in airy substance or say presence of, say we can say the dissolved solids or suspended, not dissolved solids, suspended solids in liquid, solids in liquid. So, if it is the liquid that is heating on, then it is the presence of the suspended solids that will do erosion on the surface, and if some airy substance is entering into the cell side, then what will happen that, and if it is having some dust particle into that will also heat that tube walls, and then the erosion will take place, and then cavitation because of the buckling of the tubes will buckle, and that portion may suddenly there can be some cavity that is being formed, and then the vibration, there will be huge vibration of the tubes, and because of that then it may that affect the fitting through the tube seats, and there can be a leakage problem between the cell and the tube side fluids. Okay. So, all these things are possible. So, therefore, the impingement plate is there to prevent such incidences. Okay. Then the most important part of this heat exchanger is the baffles. So, as you understand, baffle is nothing but is a metal plate in the form of segment of a circle, okay, with necessary holes to accommodate tubes. So, also that means the baffles also have layouts like tube seats. Okay. So, now what is happening is we can see that this here it is not clear. So, we can see that these are the baffles. So, these are the baffles that are placed over here. So, these are baffles which are placed, and so what we can understand is that it's a because it's a circular kind of plate that will be there, and it will be simply like a tube seat, and through that there will be some holes, and it is not equal to the it should not be equal to the diameter of the shell. In that case, that there is no passage for the shell side fluid. So, it will be there will be some segmental cut. So, the baffles will be cut into different segments. So, therefore, we can say that they are called as segmental baffles. What it does is it gives two functions it has to do. First thing is that it gives huge deviations, it provides huge deviations in the flow path. That means create huge turbulence. That is the one thing. So, to create huge turbulence, that means it indicates that indirectly it increases the heat transfer coefficient, and this is which heat transfer coefficient, and this is nothing but the shell side heat transfer coefficient, okay. Because it is linked with the shell side fluid, okay. And in addition to this, it acts as a support, okay, support for tubes. So, what is there is in the baffles there will be holes, and through the holes the tubes will be pushed and it will be ending towards the tube seats. So, they have a role like a tube seat, but only thing is that the baffles are not completely covering the shells. So, there will be at least there are two baffles should be placed to completely cover all the tubes. So, because the baffles are usually we can say that they can be vertical cut or horizontal cut baffles, okay. And then this cutting can be up to 50% cut baffles, and usually 20% cut baffles are used, but it can the range can be so 15% to 50%. In this range the baffle cut can be. So, if you try to see that when you have a baffle like this, you have a baffle like this, so this is the dimension, almost the dimension of the shell. Now, what is happening? We will cut it. So, this part. So, this cutting can be like this. So, in that case it is say roughly 15% cut or 20% cut. This cut can be in both the sides. So, that means you have the tubes like this. So, here the tubes are placed. This is a square pitch arrangement, you can understand from there. So, it is a square pitch arrangement of the tubes. It can be triangular pitch also. So, this is one cut, this is another side cut. So, these are called horizontal cuts. So, this portion there is nothing is there. So, I can say this is we can say after you cut it, then it I am sorry. So, we can say it is like this, the baffle will look like this, and this portion is initially it was there and now it is not there. So, it is like this, and there could be even the vertical cut also like this. So, then we have this say again if we say that this is a triangular pitch arrangements like that. So, these are all triangular pitch arrangements, okay, triangular pitch arrangements. So, this way also can be just typical square pitch arrangement is a typical triangular pitch arrangements for the baffles. Now, here also it can be say 15% cut, or this can be 20% cut. So, it can be in one side, it can be both the sides. So, this way the baffles are being there, and the baffles can be only one side cut. This is suppose this is only the vertical cut, but one thing is there or there can be something. So, this is the cut portion. Similarly, it can be only say this is the cut portion. So, when we say that 20% cart baffle means that area of the cart portion is 20%. So, it is based on the area of the cart portion. Okay. And then what is important here is that in all such baffles, if we see that if we say that there is a baffle like this, sorry, so suppose this is a baffle and say this is 20% cart baffle. So, we have these tubes over here like this. Now, what is there in this is there will be a small groove over here, and this groove is at this point. For all the baffles, it is placed vertically. It can be placed from both the sides of the, from all different sides of the cells, the baffles can be placed, and there is a groove that will be, which is that the portion, the groove will be attached to the portion of the cell, which is attached to the cell. So, what for this groove is that when we need to have a routine maintenance for this groove in baffle is helpful for draining out all the liquid present in the cell side, because and this draining out is needed during maintenance. Okay. So, that is being done. So, therefore, this kind of groove is there for all the baffles. And there is another point over here is that there is another kind of baffles which is of little different kind of nature, that is called disc and duff nut arrangement. So, under that situation, what happens is that, so it is like this, a baffle is there. So, this inner portion is cut, and then in this case the outer portion is cut. Then we have another baffle of this, which is inner portion is cut and then outer portion is cut. It is like this. So, that means fluid is inner portion is cut. So, this fluid is coming like this, again entering here and going like this. So, fluid is coming like this. So, what is happening? So, this is the, then it becomes the path for cell side fluid. And these portions we have the tubes, here we have the tubes. So, this we have the tubes inserted. Okay. So, this kind of arrangement also is there, and this is called disc and duff nut arrangement. This is a typical type of arrangement for cell and tube exchanger for the baffles. Okay. Now, this as you have seen that maximum of 50% cut, it is always less than the 50% cut, it is not more than 50% cut of a baffle is used, and therefore, minimum of 2 baffles are needed to really hold all the tubes in a cell and tube exchanger. So, minimum of 2 baffles, and so proper baffle spacing is needed. As you can understand, if you give more number of baffles, then also it creates problem. There will be lots of huge turbulence, and because of this turbulence we will have a lot of pressure drop, huge pressure drop, and that is also not desirable. So, we have to see that there will be some optimization between these high pressure drop and generating heat transfer coefficient, because we know up to a certain value of turbulence heat transfer coefficient increase, and after that it does not increase much. So, there should be an optimum considerations regarding the baffle spacing also, and usually the spacing is lies, the minimum baffle spacing, I should say minimum, is 1/5 of cell dia or 5 centimeter, which one is whichever is larger. So, that is the minimum baffle spacing that should be used. Okay. And then comes another important thing, that is called tie rods and baffle spacers. So, tie rod is basically a rod. From the name itself we can understand it is tying off. To tie rod, one side of this rod is screwed with the it is basically a rod, it passing through all through horizontally through the cylinder heat exchanger, and it is one side is screwed with the tube seat, okay, and other side may be screwed, or it may be permanently it may be bolted, or a different way it is built, but normally they are screwed in the with the tube seats, and these tie rods also pass through. They also pass through the baffles. So, what does the tie rods do then? They keep the baffles in right positions, upright positions we can say, okay, and they have tie rods have threaded ends fitted with tube seat, okay, and then okay, that it is screwed because it is screwed with the tube seat, and it holds the baffles in upright condition and intact. Okay. Now, in addition to tie rods, there are some baffle spacers. What is this? These are actually hollow tubes. These are hollow tubes, and which are slid over the tie rods. Okay, and it stays between the baffles, so that it maintains the distance between two baffles, keep the baffles intact. Distance between baffles intact. So, it is also a kind of supporting device we can say. So, it is, I can say that it is a supporting device. So, we can see that if we just have a look here. So, we can say that this is the tie rod, and this portion is these portions are the spacers. So, these spacers allow us to maintain a sufficient or the right distance between the baffles. It allow to maintain right distance between the baffle and the tube seat also. Okay, and also we can understand, we can see that tie rods, that this is the tube. So, the tie rods, diameter of the tie rods or the baffle spacers would be much less compared to the tube diameter. This is not to just waste any space. So, it is only very minor, whichever is needed, the minimum diameter of the rod which is needed to maintain according to the pressure conditions and according to the strength requirements. Okay, that is being put into this shell and tube heat exchanger in the form of tie rods. So, it is tying up both the tube, it is connected with both the tube seats, and in the tie rods we have at different places you have the small spacers, that are called baffle spacers, and there are two spacers will be there. One will be between the baffle and the tube seat in one side, another also in the between the last baffle and the tube seat of the other end. Okay. The next part is flanges and gaskets. Okay. So, there are various flanges and gaskets are used for these shell and tube heat exchangers, just to make this tightened, and it is for mechanical designs. And gaskets, just to know about these gaskets, are placed between. What is the gasket? Gasket is some you can say that some material which is placed between flanges to make the system leak proof. So, typical gaskets are used to make leak proof arrangements. Okay. And we can have that compressed asbestos fiber, jacketed asbestos, then PTFE, polytetrafluoroethylene. Okay. So, these are different or various gaskets used. Okay. And tube seat also acts as a flange. Okay. Now, let us come to another important point, that is called that expansion joint of the shell. What is there is that we have a shell, and a shell can have this jointed of this kind. These are expansion joints. So, we can say these portions are welded, Okay. So, these are called expansion joints. So, if there is big this joint. So, this is to absorb any thermal shock, and that is due to this thermal shock is due to large temperature difference between the shell side and tube side fluids. Okay. Now, apart from this, already we have discussed that the various other type of heat exchangers, various other types of shell and tube heat exchanger. Typically, already we have discussed, is called floating head. Then we can have say with U bundle. That means tubes are coming like this in a shell and tube exchanger, and in place of tubes being, so tubes are coming like this. So tubes have got an U bend in the shell and tube heat exchanger, and they are fixed with a tube seat. This is the tube seat, and this is the tube with U bend. So, this kind of heat exchanger are also there, where the tube bend, the bend side is a floating kind of things. Okay. So, it is just, so it will be always a two tube pass. We can say that it will be always a two tube pass for this kind of heat exchanger. Okay. So, this is with tube bend, and then there is another type that you should say, that kettle type heat exchanger. Okay. Now, kettle type heat exchanger is that you can see that here this is an arrangement of a kettle type heat exchanger. What is happening here is that in many a times we need to put say a reboiler. We know that the reboiler is a very common thing for our shell and tube heat exchanger applications. So, the heat reboilers are being used or placed with a distillation column. At the bottom of the distillation column, the reboilers are placed, and we can see that these kettle type reboilers are used. Here it is again like a shell and tube heat exchanger, but only thing is there here is this, that this portion, the cell side portion, there will be huge space is there in the cell side, and this huge space is to accommodate the vapor that is coming during the boiling operation. And this also care is being taken to see that there is no entrainment of the bubble of the liquid that will be there in this. So, this is a kettle type heat exchanger is being used for particularly reboiler operations, where we need to have some enough space for the vapor to be generated, and that vapor is gradually taken up. Okay. Now, in this case, that tubes, this head is kettle type reboiler is here it is that that's a floating head device, and this impingement plate helps it to be that no vapor will be drained. Okay. Now, in addition to this, there are some other kind of reboilers or heat exchangers are there. That's called, one is called thermosiphon reboilers. In the thermosiphon reboilers also we have the heat exchanger, shell and tube heat exchanger is used. Either in horizontal condition or in vertical condition. Okay. So, this is called thermosiphon reboiler that is being used. Now, regarding that heat exchanger, there are a few things we should understand, that we know that there is a tubular exchanger manufacturers association TEMA code. TEMA code is usually used for our heat exchanger design. And the full form is tubular exchanger manufacturers association. Okay. Now, regarding the material construction, we have told the material construction is depending upon, for the heat exchangers, it depends upon the kind of operating conditions and the kind of fluids that we are using. So, and we have to think of about the corrosion matters also. Now, so one important thing we should say about this fouling behavior. With shell and tube heat exchangers or any other kind of heat exchangers. Thus, fouling behavior, this fouling can be due to precipitation, that is happening deposition of dissolved solid or salts, then particulate deposition, deposition of suspended particles, then chemical reaction, that means deposition of particles formed after chemical reaction of materials in the fluid. Okay. So, this deposition of the particles formed after chemical reaction of this. So, this is due to the chemical. Then biofouling, this is happening due to attachment of microbial species. On surface. So, all these things, fouling means that it's basically that decreasing the heat transfer behavior, and this heat transfer behavior is decreased due to decrease in the heat transfer coefficient, and that means the surface is getting disturbed, and this disturbance in the surface is due to depositions or some kind of attachment and all these things. That is whatever we are discussing. And then solidification fouling, and this is happening due to solidification of substances, solidification of substances at low temperature operation. And then we can have, say, corrosion, that means that due to presence of corrosive fluids, reaction, surfaces reacts to form amorphous materials that deposits on the surface. So, this corrosion due to some presence of chlorides, high temperature steam, okay, oxygen and many other oxidizing agents. So, this corrosion leads to two things. It degrades the heat transfer behavior, at the same time it degrades the surface quality of the tubes and the cells. Okay. So, therefore, a routine maintenance is necessary to remove the deposits, okay, and for right performance. Okay. And this removal of the deposits take place by mechanical brushing or treatment with chemicals. Okay. Now, I will ask one simple question that in case of corrosive fluids to be handled, why are these corrosive fluid we should put into in the tube side or in the cell side? The answer would be that we should put the corrosive fluid in the tube side. The reason is, if we put the corrosive fluids in the cell side, then it will corrode both the cell as well as tube surfaces. But if you put in the tube side, it will only corrode or it will only deteriorate the tube surfaces. So, with time, when it will be beyond any repair or beyond any functions, then we can just remove those tubes. So, from the tube seat, we can remove those tubes and put some other tubes in place. Okay. So, therefore, that corrosive fluids always should be placed in the tube sides to avoid damage of both tubes as well as cell surfaces. That is the first question. There is another question that I can ask, that like what is the role of a baffle in a cell and tube heat exchanger? That we should say that role of the baffle in a cell and tube heat exchanger is fundamentally there are two roles. First one is it more technical with respect to that increase in the heat transfer coefficient, because if you put the baffle, it will change the path of the cell side fluid, and as the path of the pathway of the cell side fluid changes, there will be turbulence created, and because of this turbulence there will be more heat transfer, and the heat transfer coefficient will increase and the rate of heat transfer will be more. That is one part. And the second part is it helps in keeping the tubes intact in the cell and tube heat exchanger, because the tubes are pushed through the baffles. Okay. At the same time, these are the positive points of putting a baffle. The negative point is that we are going to lose some amount of pressure energy. So there will be a drop because of this. The fluid pathway is changing, and this fluid pathway change is happening due to, or the turbulence of the fluid is happening due to changes or due to loss of its pressure energy, and there will be a pressure drop because of application of the baffles. Okay, so that's all for this lecture. Now I'll stop over here. Then in the next lecture I will try to discuss on some compact heat exchangers. Thank you very much.